Okay, let's solve this system by graphing. And so this system, we have two equations. Let's call this equation 1 and let's call this equation 2. These equations must be in slope-intercept form so that we can graph them. So let's take equation 1, negative 2y minus 5x equals 2, and let's put this in slope-intercept form. To do that, we need to get y by itself. Let's move the 5x over. So I'm going to add 5x to both sides, so those 5x's cancel. And so I'm left with negative 2y equals 5x plus 2. And then I got to solve for y by dividing every term in the equation by negative 2. Every term in the equation gets divided by negative 2. And so now I have y is equal to negative 5 over 2. It doesn't matter where you put the negative sign. I'm going to put it in the top. Negative 5 over 2x. So negative 5 halves x. And then I have 2 over negative 2, which is negative 1. So this right here is slope-intercept form for equation number 1. Okay, so now let's do the same thing for equation number 2 so that I can then graph them. So equation number 2 was negative 5x equals 2y minus 4. I need to get y by itself. So I see that y is on this side, so let's move this 4 over. So I'm going to add 4. I'm going to add 4 to both sides, so those 4's cancel. I'm going to go ahead and put my y term first, so 2y, bring the equal sign down. Then my x term. My x term is negative, so I have negative 5x, and then this is positive 4, so plus 4. I need to solve for y, so let's divide every term by 2. Since that's the number in front of y, those two simplify, and so I have y equals negative 5 over 2, negative 5 over 2, x, don't forget your x, and then 4 over 2, that's 4 divided by 2, which is positive 2. And so this is my equation in slope-intercept form for equation number 2. And so as you can see here, before I even graph these equations, let's see what kind of solution I would expect to have. Well, I see their slopes. These are their slopes, their m's. What do you notice about their slopes? Well, here the slope is negative 5 halves. Here the slope is negative 5 halves. And so we can say they have the same m. They have the same slope. What do you notice about their b's? Their y-intercepts. This b is negative 1. This b is positive 2. Are those the same or are those different? Well, those are different, right? Their b's are different. They have different b, different y-intercept. And what do we know about systems that have equations that have the same slope and different y-intercepts? They have what? They have no solution. There's no solution. Why? We would expect that these lines never ever intersect. They never cross on the coordinate plane. And so let's graph them and make sure that those lines look like parallel lines. They look like train tracks. Okay, so let's use these equations from slope-intercept form and let's graph them. Okay, so here's our coordinate plane. We have equation 1 and equation 2. Let's graph equation number 1. The slope is negative 5 over 2. The b is negative 1. I'm going to begin at b, which is negative 1, which is right here. That's where I begin. After I begin with b, I move with m. I move with m. Because the slope is negative 5 over 2, this tells me to go down 5 to the right 2. Down 5 to the right 2 from b. So down 5, 1, 2, 3, 4, 5 to the right 2, 1, 2. I could also go in the opposite direction. Instead of going down 5, right 2, I can go up 5, left 2, up 5, left 2 from b. So up 5, 1, 2, 3, 4, 5, left 2, 1, 2. Alright, so if I connect these with a straight line, as best I can. Okay, arrows on the end of your line because this line would continue, and let's call this line number 1. Line number 1. Let's do the same thing for equation number 2. Equation number 2, I'm going to begin at b, which is positive 2. So right there, that's positive 2. Then I'm going to move with m. My m is the same thing. My m is negative 5 over 2. So down 5, 1, 2, 3, 4, 5 to the right 2, 1, 2. I could also go up 5, left 2. So 1, 2, 3, 4, 5 to the left 2, 1, 2. Okay, if I connect these with a line as best you can. Arrows on the end of your line, call this line number 2. Okay, as you can see, these are side-by-side lines. These are train tracks. These are lines that run side by side and will never ever intersect. They will never ever cross. And because they will never cross, therefore there is no solution. There is no ordered pair that satisfies this system.